Castigliano's theorem next. Let's hit that next. I don't go to the bottom line here. The way it works, let me just simplify for you. Just look at my drawing here, and then we'll get going with some examples. Say I have a beam, and I have a load applied P. If I can calculate the energy of this beam under that load P, what I can do is I calculate the energy as a function of P. If I take the partial of P respect, if I take the partial respect to P, the load P, you will get the deflection at that particular point. So if you can calculate strain energy in terms of the load P that was applied, then if you take the derivative of U, the energy with respect to P, you get a deflection at that location that you're looking at. Is that clear what I said or not? It'll become more clear when I actually do an example. Okay, here's an example of, let's see if there's a good example. Yeah, so say I want to find, say I have two loads applied, P1 and P2 in the top left. You can see that there. Top diagram has a load P1 and P2. Okay. How do I calculate strain energy for this beam? How will you do it? You have the two loads applied. You can calculate the moment in this section, you agree? By doing a free body diagram. Can I do a cut there? 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 Do you guys know how to do that? Do the cuts and then calculate the moments in that section? You know how to do that? So you agree that moment calculation is going to be a function of load P1 and P2? You agree? In this case, right? Are you guys following me or you're lost? Yeah, it should be obvious, right? So now I can take, do you agree now that I can break up these three elements, these three beam sections into three sections? First, I can integrate it for piece number one, and I'll have m squared divided by 2ei plus the second section is m squared divided by 2ei plus the third section is m squared divided by 2ei. Correct? What are the three pieces? 1, 2, and 3. Correct? Three pieces where the moment, you can calculate moment as a function of P1 and P2. Once you add these strain energies for the three little pieces that you see there, you have to make sure your integral, the integral, what do you call it? The integral limits are correct, right? For that beam section that you're looking at. Once you're done with all that, all you have to do is take the derivative and set this U. So say I want to find the deflection at point 2, this point here, at load 2. What I'll do, I'll take the derivative of U respect to P2 and set equal to, that's the deflection you'll find. That's how you do it. So if I want to find the deflection here, I just have to do this derivative to find the deflection there. That's all I have to do. Is that clear or not? Yes? Same with this method. I can apply, find the energy of the whole system. And then I can find the derivative of U respect to, in this case, is load P there, where I apply the load P. And that'll give me the deflection of that particular point, the deflection of point B. So it's a very similar method as what it's discussed before, but now it's using Castigliano's method, which is pretty much a very similar method as what I discussed. Yeah, very straightforward. Here you can see some calculations I did using chain rule. When you're taking the partial of something, where that something depends on something else, you have to use chain rule. And so the force F in each of the bars depends on the load P. So you first find the derivative of this with respect to F. And then once you do that, you find the derivative of F with respect to P, which is what you see there. But you can also, you don't have to even use that formula. You can just use this formula, derivative of U with respect to P. Guarantee you'll get it right, just doing that. Just step by step. Okay. So any questions so far before I move to examples?